So yesterday we have discussed uh, some features of the source coding, as well as we have discussed the formula for the average code length. So one thing also, those who have not still noted down the formula of average code length, it is displayed on the slide. Please note it down. That is L is equal to sigma k is equal to 0 to k minus 1 pklk, and the unit is letters per message. In per message, how many letters they are? Okay, so bits and letters are a little bit different things. So take this difference on your mind, that it is having the unit letters per message. And similarly, at the same time, I have described the condition of average code length, that should be always larger than or equal to source entropy, and also it should be less than source entropy plus 1, means hx plus 1. It is always greater than hx but less than hx plus 1. So to understand this concept, we have to take one of the example that would be explain the theory of the source entropy. You can see there is a example of robot, and it is a path following robot is there, and it could be walk on 4 directions. So these directions has been shown here: east, west, north, and south. Probability of robot to walk in the south direction is 1 by 2, in the north 1 by 4, in the east and west both are equal probability 1 by 8. So what is the average information of entropy of this robotic source? So this would be calculated with the help of the formula minus px log px raised to px. So here I have taken the negative sign to simplify our calculation, or you can take the formula px log base to 1 upon px. Either of the formula you would be used, you would be get the answer this 1.75 bits per symbol. It is not second, it is bits per symbol or per message. Okay, so this is the entropy of the robot. Now we have to be calculate the average length, code length, by using the prefix coding. You can see in the second slide related to the same example, here very few students are attending the lecture, only 36. I would be now message to your friend, otherwise I would be block this lecture after 5 minutes. They are actually coming only for attendance at the end of the lecture. So I would be going to block today after 5 minutes. Okay, now see here on this example of the robot, if you would be see, so this source has been the symbols has been the, that is the direction actually, south, north, east and west, having the probabilities mentioned in the statement, that is south is having 1 by 2, that is 0.5, then north is 1 by 4 and 0.25, and east and west is 1 by 8 means 0.125. Now we can encode this information by the two way. One is a fixed length code word, another is a variable length code. Okay, so when you are using the fixed length code, and both the code should be prefix code, means no code word could be become the prefix of the other. So you can see here in the fixed length code word, that is not a possibility of prefix coding, but in the variable code word also, it has been taken the care that no code word would be become the prefix of the other code word. Okay, then and then only it is a correctly representation of the codes. Now you can see if you are using the fixed length code word, so these are the some coding for the south 00, north 01, east 10, and west 11. And for the variable length code 0, 10, 110, and 111 for the west as per the direction. Now, if we would be see the symbol stream, this is the symbol stream that how the robot would be walk. First, it would be walk in the south, then again south, then north, then west, then south, then east, north, northwest, three times south, then north, then east, then again two times south. So this is the movement of the robot. If you use the fixed length code, so the code word corresponding to the direction would be south 00, then again it is south 00, north 01, west 11, south 00, east 10. Like this, all the coding has been be completed here. And when you are using the fixed length coding method, you would find that for this walking pattern of the robot would be encoded with the help of 32 bits. But if you would be going to use the variable length code, then you found that it would be only text 28 bits. Means what? When you using the variable length code as compared to the fixed length code, it would be saves your data. It would be take less amount of bits to encode the information, and here you are going to save the 4 bits by using the variable length coding technique. So in this way we can say that variable length code word is preferred over the fixed length code. Okay, so now we have to be learn the next point, that is coding efficiency. So if you would be going to calculate the code efficiency, so what is the phenomena behind it? We use the encoding methods that would be gives rise, just a minute. Okay. So encoding methods give rise to uniquely decodable code, and the efficiency can be improved by representing higher probability message by the less number of bits. Okay, so that we have already discussed. Those messages having the higher probability, that should be encoded with the less number of bits, and those having the less probability, that would be encoded by the higher number of bits. Okay, so we can define the formula of the code efficiency by using the term eta. Eta is equal to h of x upon L. H of x is here source entropy, and L is the average code length. Okay, and this formula is actually valid for the binary codes. When you are using the binary numbers for the coding of the information, then we use this formula. And our aim is that eta should be equal to 1 for 100% efficiency. Okay, so an efficient code means eta should be equal to 1. But if you are using in the binary coding, we use only 2 levels, either 0 or 1. But if you are using multi-level codes for encoding the message, at that moment this formula would be modified. So see the modified formula. then eta would be equal to hx upon L into log base 2 capital M. So this is the modified formula for finding out the code efficiency when you are using more than 2 labels to encode the message. So you can generally labels are what? Binary 0 is representation of the some voltage level, suppose 0 volt. Binary 1 is representation another voltage level, suppose plus V. So maybe it is a possibility that you are using the multi-level codes. At that moment, you would be required to use the some other voltage levels like minus V. So there is a 3 levels. So at that moment, the previous formula is not valid. At that moment, this formula would be valid for the code efficiency. Or conclusively, you can only refer this formula. Eta is equal to hx upon L into log base 2 capital M. Here the log base 2 capital M is what? It would be a maximum average information associated with each letter, and its unit is bits per letter. Okay, so hx is having the units bits per message. L is having unit letters per message. Then again it would be bits, log base 2m is bits per letter. So in this way you can see that it would be become unitless now. Eta would become unitless now. So letter would be cancelled, bits upon message bits upon will cancel out. Okay. So in this way you can say this is the perfect formula for finding out the code efficiency. But otherwise, in the previous formula, if you have not take the term of log base 2m, so at that time you would be difficult to justify the eta is a unitless quantity. Okay. In sometimes we would be refer letters also as a bits, but if you would be go in a detailed description of this information, letters and bits are little bit different. So for binary code, letter would be 0 or 1, so M would be 2. So log base 2 is 1. So you can neglect the term log base 2m for the binary coding. But if you had a multi-level coding, you have to mention this. We would be see from the examples. Now, if you would be come here to the one of the example of this code efficiency. So here you can see in the table we have used the 4 message symbols xk, that is x0, x1, x2, x3, x4. Sorry, x0 to x3. 4 message symbols are there, each having the probability that is also given in the table. And there is a 2 coding methods are used, code 1 and code 2. In the code 1 we have used the fixed length code word, and in the code 2 we have used the variable length code word. So when you are using the fixed length code word, it is fixed code word length, that is 2, that is represented in this table. But when you are using the variable length code word, every symbol having a different length. Maybe like x0, the corresponding code word is 0, so it is 1. Then the length for x1 is changed to 2, x2 and x3 has been 3. Okay, so variable length is here. Now we have to find out the entropy. Entropy would be same for both coding method, either it is fixed length code or the variable length code. Hx would be remain same, and it is coming out 7/4 bits per symbol, or you can say 1.75 bits per symbol. Now find out the efficiency for code 1 and code 2. For the code 1, average code word length L would be equal to 2, but for the variable length code word L is become 7 by 4 means it is less than 2. Okay. So in the case of code 1, efficiency would be entropy upon L, that is 0.875, means 87.5%. But when you are referring the code to, that is a variable length code, at that moment the entropy and the L would be same, so your efficiency eta would be equal to 1, that means 100%. So in this way we can say that code 2 or variable length code word is a more efficient technique as compared to the fixed length code. And one another way to judge which is the better coding, that by seeing the value of L. Those method having the value of L is less as compared to the other, that would be more efficient. Okay. So this is the description of code efficiency. We have taken one example also. Now come to the another topic, that is Shannon-Fano coding. It is also called as Fano coding. So the Shannon-Fano code, everyone please note down the procedure because it would be helpful for you for solving the numericals. The Shannon-Fano code is a technique for constructing a prefix code. It is a suboptimal in the sense that it does not achieve the lowest possible expected code word length like Huffman code. So you can say as compared to Huffman coding, it is little bit has a drawback that it does not achieve the optimal efficiency. Now you can see the, however, unlike the Huffman coding, it does not guarantee that all code word lengths are within the one bit of their theoretical ideal, like log 1 upon px. It could be only achieved with the help of Huffman coding, that would be learned in later on. Now we have to see the procedure for the Shannon-Fano coding. If you would see the application of Shannon-Fano coding, it is basically used in the implode compression methods, that is a part of GIF file format. We see the GIF file format in the computers when we use the computers, and lots of the multiple files could be zipped to compress the size of this particular file. We use the GIF format. So at that moment, this Shannon-Fano coding could be used for encoding and decoding of that compressed file. So now see the procedure. First step is arrange the information source symbol in order of decreasing probability. So first of all, you have to arrange the information symbols into a order of decreasing probability, means highest probability would be at the top and lowest probability would be at the bottom. Then second step is divide the symbol into two equally probable groups as possible as you can. Means it is not guarantee that in each time, in each division, you would get the equal probable message at the above and below of the division. Maybe the unequal probability division could be also there, but you have to try to make it two equally probable groups as possible as you can. Third step is each group receives one of the binary symbols, that is either 0 or 1 as a first symbol, and repeat the steps 2 and 3 per group as many as this is possible. So the first step is what? Repeat the step number 2 and 3 per group as many times as this is possible. Okay. So this is the procedure for encoding the information with the help of Shannon-Fano coding technique. So just note it down, these particular steps that would be going to use further. Now we would be, and the last you can also add, this is the step that stop when no more groups is available for division. So these are the steps. You can take the screenshot also, or either note it down. Okay. Now we have to be take one of the example to understand the Shannon-Fano code. So this is the example where we have taken some symbols that is represented with the help of the English alphabet A, B, C, D up to J. So there are the 10 symbols we have taken, and each symbol having some probability, like A and B having the probability 1/4, C and D having the probability 1/8, E and F having the probability 1/16, and G to J having the probability 1/32. So we have arranged the information source symbol, that is from A to J, according to decreasing probability. It is not like that after A there would be, in English there is a B would become, so we would write the B next and then C, like this. We have arranged according to the value of the probability in the decreasing manner. Now according to Shannon-Fano code, we have to be, second step is what? The divide the symbol into two equally probable groups as possible as you can. Okay. So in this case, you can see we have divided this into two equally probable message. So you would be sum up. We have taken the division where the above the division there is only the two symbol A and B, and below the division there is a 8 symbol from C to J. So when we would take the sum of these two, it would become 1/2, and take the sum of this, this would become 4/32, then 2/16, and 2/8. So it would be 1/8, 1/8. So it would be 4/8. That is further 1/2. So in this way, you can see they are perfectly divided into the two equally probable message. Okay. Now, as per the division, what we have to be do? We have to be write the binary 1 and 0. So here we would be use above 0 0 and the below 1 1. So you can see in this the next point, each group receives one of the binary symbols, either 0 and 1. So generally we use above the division as binary 0 and below the division as the binary 1. So A and B would be received binary 0 and C to J would be received the binary 1. Now the next step is what? What is the first step? Repeat the step number 2 and 3. So repeat step number 2 and 3 per group as many times as this is possible. So now there is a two groups available, AB in one group and C to J in the another group. Now we have to be do the division on the first group, that is AB. So again we have to be divided into the two equally probable message, that is 1/4 upon 1/4. Okay, and you would be write the above the division and below the binary 0 and 1. You can see here it would be again written binary 0 and binary 1, like this. Now we have to be moved to the second group, that is C to J, and again we would be try to divide it into two equal probable message. So it would become as 1/8 1 upon 8 again, and 1 upon 4. So it is 0.25, 0.1. So you can divide it like this: one C and D in one group and E to J in the another group. You can see. So for A and B, coding is completed. So we have make it lighten. Now see the another group. Divide the symbol into equally probable group. So just I have told you that C and D in one group and E to J would be in the another group. So according to our division for equal probable message, we have written above the division there is a 0 0 and below the division there is 1 1. Now these two would be not take the participation because it is already completed. So as it is completed, we would be not further allowed any other binary number to A and B. Okay. So now the further division would be, now again we have the two groups. First group is CD, another is E to J. Again divide the CD into the two equal probable message and then rest of the in the other equal probable message. Okay. So see the next step. Repeat the step number 2 and 3. Again we have taken a division and divided the our first group, that is CD, into two equal probable message 1 by 8, 1 by 8. So here 0 and 1 has been be put up. Now C and D, coding of the C and D has been be completed. Now it is not a further division. So already it is completed A and B. Now C and D is also completed. Only the remaining is the group E to J. So when you have to become to the, again we have make disappear the A to D because it is already completed all four. Now the only group is E to J. Again divide it into the two equal parts. So the two equal division is E, F, and another is G to J. So again we have to be divided into the two equal parts, and these two equal parts are 1 upon 16 and 1 upon 32 up to the next point. So again there is a partition. Now again we have the two groups E, F and G to J. Again we have to be do this, and above the partition there is a binary 0 and below the partition there is a 1. Again there is a possibility of division between E and F. So again we have to be do further partition. For this you can see in the next step. So again we have done the partition here for E and F for two equal probability. So it would be encoded with the help of the 4-bit message E and F, and this way up to F we have done complete the coding. Okay. Now the remaining group is G to J. So there is only 4 messages are remaining. So again we have to be do the partition. The partition would be G and H would be one group and I and J would be in the second group. So do the partition. So equal probability message, and then allot the binary numbers. So again GH would be binary 0 and I and J would be binary 1. So again there is a one chance for do the further division between G and H. Okay. So we have to be see in the next point. Again we have to be divide into the two equal probable symbol between G and H and allocate the binary numbers. So you can see in this particular slide, in the next step we have again do the equal partition and allow the binary 1 and 0 and 1 to the G and H correspondingly. So in this way up to this point we have complete the encoding of up to H. Only the remaining is 2 I and J, both have the equal probability. You can further divide it and allocate the 0 and 1 like this. You can see in the next slide. So in this way, we have allocate the binary symbols to each group that by dividing it continuously in equal probable groups. So in this way, binary you can see there is no any more group to divide. So we would be stop the division process and allocation of the binary numbers. So in this way, symbol A to B, A and B has been B, the length of 2, C and D having the length L is equal to 3, E and F having the length is equal to 4, and G to J having the length is equal to 5. These are the value of the L. So this is the variable length coding. So Shannon phenomenon is a example of the variable length coding. Now we have to find out the efficiency of this example, whatever the code word we are used. So we have to be first of all find out the average code length, that is L, and entropy. So entropy is very much simple, that I have written here. The 2 times 1 upon 4 A for A and B, this is for C and D, this is, and for E and F, this one, and the last 4 ones for the G H I J. Okay, so in this way you would be got 2.875 bits per message, the entropy for the given example, and the average code word length is sigma k is equal to 0 to k minus 1. Here the k is if you have to be see 0 to 9. Okay, so because there are the 10 symbols are there, the 0 to 9, so it would be, yeah, then you have to be right. So A and B having the code word length is 2, probability is 1 upon 4, so there's a 2, so 2 into 1 upon 4 into 2. Then again C and D, it is having probability 1 upon 8, and the code word length is 3, and this is a 2 times because C and D, two different messages are there. Then again E and F having the probability 1 upon 16, and the length is 4, code word length is 4, and there's a 2 times again. And further, if you have to be see G H I J, that is having the probability 1 upon 32, and code word length is 5, and it is 4 times because there are 4 letters are there. So in this way, you can calculate the L, and L would become again 2.875. In this way, you can see HX and L having the similar value, but it is unit is letters per message, that is having the bits per message. And here one more term you can add, that is log base 2m. Since it is a binary, so m is having the 2, so it would be become 1. So you have being the 100% efficiency for this particular coding technique. Okay, so in this way we have, using the Shannon code, we have encode the message, given symbol, input symbol into the code word. Now there is a 4 minutes only remaining. I allowed everyone, please put up your attendance. Still some students are trying to admit into the class, but I have not, I blocked the meeting. So inform them from the next time to not try to enter at the last moment. You have to be attentive from start to end of the lecture. Otherwise, I would be blocked. Okay. Now, on the basis of the same discussion, this is the assignment for you to solve this. Okay. This is the homework for you to solve this. In the next lecture on Saturday, we would be go for the Hoffman coding, and if the time permits, we would be discuss. This is very simple numerical. Some of the hint, there is some time are remaining, so I would be give you the some hint that whatever we have discussed till, according to that we have to be solve it. So first of all, you have to be make a table. So in this table, you have to be write message, then probability, then there is a length. Sorry, encode message. Length would be later on. Encode message, and finally there is a length. So spacing for the encoding is larger. Please keep it larger. Okay. So when you would be do this, so you would be first of all write the message in decreasing order probability. So the highest probability is what? That is 0.4. So it is x1. Then 0.2, x2. Then x3 is 0.12. Then x4 is 0.08. x5, x6, 0.08, 0.08, and x7 is 0.04. Okay. Now we have to be divided into two equal probable message. So just take it the summation. There is a two method actually. Okay. So for doing this, so I am explaining a method one. You can go for the method number two, or either. If you have to be see how to divide into the equal to equal probable message. So 0.4 and 0.2 is total of 0.6, and just do the summation from x3 to x7. It would be 0.2, 0.2, 0.4. So in this way, you have to be just divide it into the two equal parts. Okay. Now just write the binary 0 and rest of the x3, x4, x5, x6 and 7 as binary 1. Okay. Now in the next step, again there is a chances of partition here. So we have to again do the further partition. So it would be again next partition is that is 0 and 1, and similarly for the next partition here